Okay, so welcome back to another video. So today's question is going to be in the form of a systems of equations problem. So we're given three numbers that are real numbers, a, b, and c, such that we have this systems of equation, a plus 1 times b plus 1 times c plus 1 equals 3, a plus 2 times b plus 2 times c plus 2 is equal to negative 2, and a plus 3 times b plus 3 times c plus 3 is equal to negative 1. Then we want to find what a plus 20 times b plus 20 times c plus 20 is equal to. So typically when we're looking at, in terms of systems of equations, when we're giving however many values or rather expressions in that system, typically one may look at it as if we can find some sort of general pattern without having to do a little bit more towards using some algebra to solve for the variables. But, in this case, we have a plus 20 plus b plus 20 plus c plus 20. So one might suspect that we have to solve for the individual variables on its own, but in some situations, you don't have to do it in that case. In today, we're actually going to do a little bit of a clever substitution. And this is more of a think outside the box technique than how you are taught typically in algebra when you're solving with systems of equations. So with that in mind, if we just apply that clever substitution that we'll be doing with, then the rest is history, that it's actually pretty straightforward to solve for specifically what we're looking for, rather than the variable itself. Instead, we're looking at it in terms of quantity rather than specifically the variables. That was a little bit redundant, but with that, let's actually just jump right in. So what we'll do here to do the clever substitution, suppose that I'll let capital A, we'll substitute this for a plus 1, and we'll let capital B, we'll let that be lowercase b plus 1, and then capital C equals lowercase c plus 1. So if we just substitute everything back into here for the new, so we'll have a new systems of equations. So first we'll have a times b times c, that'll just be simply equal to just positive 3. Then put everything back into here. So now what we'll have now is capital A plus 1, then times capital B plus 1 times capital C plus 1 is equal to negative 2. And then next from over here is that we'll have capital A plus 2, then times capital B plus 2, then times capital C plus 2, then set that equal to negative 1. Okay, so to continue forward on how we want to solve what we want to do, so let's actually expand these last two equations out. So let me actually write this in terms of like a new systems of equation. So we expand all of this out. So let's start with the first one, the middle one specifically. So we'll have that expanding this, we'll have a times b times c. Add this with a times b plus a times c plus a, or b times c. Then add this with plus a plus b plus c, and then add this with 1, set that equal to negative 2. So that's expanded. So now let's actually move on to the second one. So of course that'll be a times b times c. Add this with, so actually this is going to be 2ab plus 2ac plus 2bc. Let me actually factor out the 2 from that. So 2 times ab plus ac plus bc. And then next from over here, we'll have 4a plus 4c for that expansion. I'll factor out the 4. So 4 times a plus b plus c. Add this with 8 and set this equal to negative 1. All right. So now let's actually notice that because we have that a, b, c, we set that that's equal to 3 from that substitution. So we can actually just substitute positive 3 back into over here. So if I have a 3, then add this with 1, then subtract that sum together. So minus 4. So that means that'll actually be set to negative 6. So let me actually write this out in full first. Okay. And then back to the second equation, we have that ABC. Yet again, it's still 3. So 3 plus 8 is 11. And subtract that. So that means that'll be set to negative 12. So that means now I actually even factor out the 2 from all this, of course. So that means I have 2 times AB plus AC plus BC. So factor out that 2. So that means plus 2 times A plus B plus C. And that means that's set to equal to negative 12. All right, so what we need to do is now let's actually get a little bit creative and solve for the systems of equations for specifically these two right here. So from the middle and the last. So what I can do here is let's actually multiply a negative 2 to the top equation. So that means I have negative 2 times AB plus AC plus BC plus A plus B plus C is then just equal to positive 12. Then on the bottom, of course, we're gonna have still the same thing. So AB, AC plus BC, add this with 2 times a plus b plus c. That's still equal to 12. So if I add these two together, notice that the AB, AC, BC from multiplying with the 2, those cancel out. So then I'll have, then I'll distribute the 2 back into here. So I have negative 2 plus 4 of a plus b plus c, and then this is actually just going to cancel to 0. So now I have that this is going to be 2 times a plus b plus c is equal to 0. Then we know that a plus b plus c is equal to 0. So we don't have to necessarily solve for, as mentioned, the individual variables itself. Sometimes you have to get a little bit creative when you're solving these systems of equations, and that's actually really one of the goals of what we'll be dealing with in order to help achieve to find the value what we want to solve for. So a plus b plus c is equal to 0. Okay, so if I just go back to over here, so that means I have that, or rather here, so ab plus ac plus bc plus 0 is equal to negative 6, then we can actually lead to the conclusion to say that AB plus AC plus BC is then equal to negative 6. And now we have that, of course, ABC is equal to positive 3. So that's actually all we need. We just need these 3 variables, or rather these 3 equations, such that we'll be able to solve for what we want to achieve. So A plus 20 plus times B plus 20 times C plus 20. So with that, let's actually, get to that final evaluation. So as that clever trick mentioned, so we did what a plus 1 to put in the gaps. So we could actually do a similar situation over here. So that means, so we now denote these 3 dots just to signify therefore, so just to complete the final evaluation. So we have that a plus 20 times b plus 20 then times c plus 20. In other words, we can actually write that as the same thing from that substitution, which is capital A plus 19 times capital B plus 19, then times C plus 19, capital C plus 19. Then if we just substitute all this out, well, for one, let's actually expand this out first. So what we get is this is ABC, then plus 19 times, so this is actually factor out from all of that. So 19 times AB plus AC plus BC quantity, then multiply, or rather plus 361, then multiply with A plus B plus C, then of course add this with 6,859. That's from that entire expansion over here. So we can now substitute that we set that ABC is equal to 3 plus 19 times, so AB plus AC plus BC, which is negative 6, plus 361 times A plus B plus C, which we set that's equal to 0, and add this with 6,859, which if you put all this, simplify, calculate all this out, we'll get that the final answer for A plus 20 times B plus 20 plus times C plus 20 is just 6,748. The final answer to what we want to achieve given for the systems of equations that we're given with. So you gotta think outside the box, don't solve for the individuals. That's basically the takeaway on how we want to solve, depending on what the systems of equations we are given with. So yeah, that's pretty cool if you ask me.